We continue with our series of videos on kinematics problems without a calculator. And here, specifically, we are going to start dealing with freefall problems. Doing problems without a calculator for one-dimensional freefall. That is, objects that are just going up or coming down. And when we do that, there are two assumptions that we are going to make. The first is that the acceleration due to gravity is equal to 10 meters per second squared in the downward direction. So sometimes you want to call that negative 10 meters per second squared, but it doesn't matter, positive or negative. The point is it's downward. Similarly, air resistance is negligible. We know that G on Earth is closer to 9.8 meters per second squared, but that's pretty close to 10. And so for doing problems in our head, we don't want to use 9.8. We want to use 10. If an object in free fall is moving upward, now here's one other thing we talk about in first year physics. The term free fall doesn't mean it's falling downward. It just means that it's in the air with effects due to gravity only. Gravity is the only force. So if an object in free fall is moving upward, that is, if its velocity vector points that way, then it is slowing down. And we know that because which way does the acceleration vector point? The acceleration vector is always pointing downward because gravity is always acting in that direction. And if the velocity and the acceleration vectors point opposite each other, the speed of the object is slowing down. If an object in free fall is moving downward, then it is speeding up. Specifically, it is going to be slowing down 10 meters per second every second, or it's going to be speeding up 10 meters per second every second. And hopefully you'll see that when we do a few problems here. So in each case, we want to determine the vertical displacement, and we want to assume that the object is launched or released from whatever elevation allows it to not hit the ground in the time interval that it's given. We might be at the edge of a tall cliff if we're firing something downward or whatever, but in any case, this thing is in the air the whole time that's listed. All right, an initial velocity of 0 means we're just dropping this object. So after 1 second, it's going to be traveling negative 10 meters per second. After 2 seconds, negative 20. After 3 seconds, negative 30. After 4 seconds, negative 40. Or you could say 10, 20, 30, 40 downward. That would be okay as well. Well, what's the average? Started at 0, ended at negative 40. So the average, I'll go ahead and show a little work. I'm not going to show this for each of these because we want to go as quickly as we can. The average is negative 20 meters per second. That is 20 meters per second downward. For each of 4 seconds, 80 meters downward. Boom, just like that. Number 2 here. Now we're at the edge of a cliff, but now we're throwing the ball downward, assuming it's a ball, throwing it downward at 10 meters per second. Well, 1 second later, it's going to be going 20. It's going to be going 30. It's going to be going 40. And after 4 seconds, it's going downward at 50 meters per second. What's the average? Started at 10, ended at 50. I'm thinking the average is negative 30 times 4 seconds, 120. All right, or if you want to say 120 meters downward. It does say in the problem here at the top of the screen, find the displacement. So we should either put a plus or minus sign, or we should signify the direction. And to be consistent, I'm going to say that downward is negative. Moving on, we got to finish all 8 of these, so we're going to cruise pretty quickly here. Now we're throwing the ball, if it's a ball, upward at 10 meters per second. Well, 1 second later, it will have reached the top. It won't be moving. And now, 1 second after that, it's starting to come down. It's going down faster, going down faster. 1 second, 2, 3, 4, 5. There we go. Started at positive 10, ended at negative 40. What's the average? 10 minus 40 is negative 30, cut in half. So I'm thinking that the average is negative 15 meters per second. For each of 5 seconds, how about negative 75 meters? Moving right along. We're dropping this object. 2 seconds later, how far is it gone? After 1 second, it's going negative 10 meters per second. After 2 seconds, it's going negative 20. What's the average? Negative 10. For each of 2 seconds, it's displaced downward. Whoops, not meters per second, meters. That's how you can do this kind of thing in your head. It's a lot quicker to do it this way than to use 9.81 and rely always on your equations, which is not a bad thing, but sometimes time is an issue and you need to go quickly. All right, here we go. We're throwing this thing upward at 65 meters per second. After 1 second, it's only going 55. It's going to be slowing down now, then 45, then 35. What's the average? How about 50? Times 3 seconds, 150 meters. It's that fast. Moving right along. We're throwing something upward at 35 meters per second. After 1 second, it's going 25. 2 seconds, it's going 15. 3 seconds, it's going upward at 5 meters per second. At second number 4, it's starting to come down now. Second number 5, second number 6, second number 7, second number 8. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8. 8 seconds. Started at 35 up, ended up going 45 meters per second down. What's the average? Well, add those up. That's negative 10 divided by 2 is negative 5. The average, negative 5. How about negative 40 meters? All right, 2 more. We got to hustle here. Throwing downward at 15 meters per second for 7 seconds. 1 second. 2 seconds. I'm counting the speed here. 3 seconds. 4 seconds. 5 seconds. 6 seconds. 7 seconds. After 7 seconds, it's going negative 85. It was going negative 15. What's the average? Negative 50. Displacement, 350 meters down. Last one. Throwing upward at 75. After 1 second, it's going 65. Then 55. 45. 35. 25. That's 5 seconds. Started at 75, ended at 25. What's the average? 50 times 5 seconds, 250 meters higher than the launch point. That's how it's done.